Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is update queries, and it is a medium level problem. So today's problem is pretty interesting, and I'm saying it is interesting because it can be solved in two different ways, and both of those ways take it to the higher end of the medium range of difficulty. So let us quickly start with the problem statement first. Now the problem statement says that we have been given an array of n elements and each of those elements is 0 initially, right? And we have been given two queries in the form of L, R and X, and for each query what we have to do is we have to take the bitwise OR of all the elements in the range L and R with X, right? After we do this bitwise OR operation for all the queries, we have to return the final array which has been formed. So like till now you must have observed pretty much like the first approach that we can solve this question is with range query data structures like segment trees with lazy propagation. So we are not going to discuss the approach with segment trees. The reason is I find it pretty standard and you will be able to do it easily if you know what are segment trees and if you know its implementation, right? So doing this question with segment trees is not much of a task, as well as like if you are trying to code segment tree on your own, there are chances that you might miss one or two things and you'll waste much time debugging your code, right? So let us discuss another very interesting approach which can be used to solve such similar problems of ranges, where you have been given some array and you are given some ranges to work with, and you have to just perform some operations and at the end you have to print the final array, right? So this particular approach will work on all similar problems. So let us quickly start with the approach. How are we going to use this? So first of all, let us just reiterate what the question has to say. For example, if from the range 1 to 3 I have 1, again from the range 1 to 2 I have 2. So what I initially have to do is I have to so initially all of them, right, can be 0, and I have to do bitwise OR of all the elements with 2 in the range 1 to 2. So this element will become 2, this element will become 2, and then I have to do bitwise OR of all the elements in the range 1 to 3 with 1. So 2 is essentially like this, and if I do bitwise OR with 1, it will become like this, and it is equal to 3. So this will become 3, this will become 3, and this will become 1, right? So this is our question, and we have to return this final array at the end. This is what our question is asking, right? Now let us for a moment, let us just discuss at each index what is the contribution made by each variable x, right? Now for now let us just forget about taking bitwise or anything. We are just talking about the contribution of each element x at each index I, right? So this is very important. So to simplify the problem even further, what I can do is I have removed the right range completely. So we can just forget for now that there exists a variable r. So in our input, we just have two variables L and X. So L denotes the starting of the range and X denotes the integer, any integer X, which will contribute to our ith index or any index for that matter, right? So now if I want to calculate what are the integers, like which of those integers X will contribute at my ith index. So let me call it answer of I, right? What are the integers or what are the variables X that will contribute to my answer of I, right? So the answer to this question is pretty simple. That would be all the integers which are starting from 0, because we have been given a left range and there is no right end to it. So for the ith index, all the integers, all the ranges that are starting from 0 plus all the ranges that are starting from 1 up to all the ranges that are starting from I, right? So this part is pretty simple, that if I am considering only the left range, then my answer of I would be equals to this, because all the integers starting from 0, 1, 2 till I will contribute to my answer, right? Now let me just give you a more graphical representation of this. For example, this is some kind of an array, and there is a range starting from 0 like this. There is a range starting from 1 like this. There is a range starting from 2 like this. There is a range starting from 3 like this. So if I want to talk about I is equals to 3, you would observe that the element, that the range starting from 0 is also contributing here, range starting from 1 is contributing here, range starting from 2 is contributing here, as well as the range starting from 3 is contributing here, right? So this is how I have formed this formula, right? So this is the first part of the question. Now let me just introduce a range R, or the right end of the range. Now there will be some changes to my answer. What are those changes? So if I've already computed this part of the answer, then answer of I'll have to update answer of I. And what I'll do is this will be equals to answer of I minus something. Because for example, if there was some range starting from some element, but it already ended before even reaching our index I, then it should be removed from our answer, right? For example, if I am at index 3, then the range starting from 0 was earlier contributing to my answer when there was no right limit to our range. But if for this particular range the right limit is 2, then this range will already end before even reaching 3. So I should not consider this range, right? So all the elements which have ended at 0, or which have ended at 1, or till which have ended at I minus 1 will not contribute to my answer, right? So what I have found is, for any index I, all the ranges starting from 0 till I will contribute to my answer, excluding the ranges which have ended from 0 till I minus 1, right? So this will be my contribution of the numbers at any given index I. Now we will try to generalize this formula even more. Let me just write it clearly once. So answer of I is equals to element starting from 0 will contribute, starting from 1 will contribute, and so on up to starting from I will contribute, excluding the elements which have ended at 0, or which have ended at 1, up to which have ended at I minus 1, right? Now if we try to find or try to traverse through all the elements from 0 to I, 0 to I minus 1 each time, this will take a lot of time, right? Obviously. So we will try to generalize this formula even more. I'll try to find answer of I minus 1. Let us just observe what happens if I try to find answer of I minus 1. So it will still be start of 0, it will still be start of 1, up to start of I minus 1, right? Similarly, all the elements which have ended at 0 will not be included in the answer, which have ended at 1 will not be included, up to which have ended at I minus 2 will not be included, right? This part is clear. What if I try to replace some data in this particular area with answer of I minus 1? You will observe that it is already possible, some of the part is already repeated, right? I have already computed till I minus 1, then I don't need to compute it here again, right? I only need to compute for start of I. Similarly, if I've already computed till end of I minus 2, I don't need to compute it again here. I just need to compute for end of I minus 1. So in any general case, answer of I would be equals to answer of I minus 1 plus start of I minus end of I minus 1. That's it. Now we have found what are all the elements that will be contributing to the ith index, right? So this is a very general formula to find the contribution of all the elements which are contributing at the ith index. So what are all those elements? So all those elements would be the elements which have been contributing to the I minus 1th index plus all the elements which have started from the index I, whose range have started from the index I, minus all those elements whose range have ended at the index I minus 1. So this would be my general formula. So once I have found out what are all the elements that will be contributing to my current index I, now I can just take the bitwise OR of all those elements and print my final answer. So how do we do this addition and subtraction? For example, let me just take an example. For example, all those elements till index I minus 1, the bitwise OR, let us just assume that the answer of I minus 1 is 5, right? So the answer of I minus 1 is 5, or let me just take it 4. This is 4. So, and there is an element starting from index I and it is extending till I plus 2, and this is 1, right? So start of I would be, there is one element which is starting at index I and its value is 1. So what I can do is I can just store the bitwise information of this value. So initially my 0, 1, 2. Initially my answer of I was something like this. I want to include start of I as well. So this is 1. I'll take it bitwise value and I'll update it like this. So it will be 101. Now for example, there was some element which ended at index I minus 1. So let us say it was starting from 0 and it ended at index I minus 1 and the value is 4. So what I'll do is I'll subtract the frequency like this. So in this particular array, I'm not actually maintaining the bitwise the number in bitwise form. I'm actually maintaining the frequency of each of those bits, right? So why am I actually maintaining the frequency? Because there might be a case, for example, if you're dealing with some numbers and some numbers have the same bit I set, right? So for example, if I take 1, 3 and 5, right? If all of these numbers are together and all of these numbers lie in the range 1 to 3. So range 1 to 3 will have, so this is the bitwise frequency 0, 1, 2, 3. So the frequency of this will be 3. The frequency of this will be 1 and 1, right? So because 111 is 5, 101 is 5, 3 is 11 and 1 is 1. So I'll be maintaining an array like this. Why? Because now if I want to remove an element 0, 1, right? So even if I remove 1, then the other two elements would still be contributing to the answer, right? So that way my answer should not change because I still have some elements which will be contributing to the 0th index. Why? Because when I am taking the bitwise OR, even if one of the bit is set, I need to consider it. That is why I am maintaining the frequency of each of those characters. However, if the question was bitwise and I would have just like used it like a boolean variable, because even if one of the variables is not set, then the whole answer should be 0 at that particular index. But if in this particular case I will have to maintain the frequency, because even if I remove this particular one, the other two would still be contributing and the frequency left here would be equal to 2, right? So I will have to consider this. This is how we will be modifying this particular thing, this particular general formula to our question by maintaining the bitwise frequency of at each of the indexes, right? So let me just go through the question once again. What the question is? So it says that we have been given q queries in the form of L, R and X, and we have to do the bitwise OR of all the elements with X in the range L to R. L to R. Right. Now, I have already discussed that answer of I would be equals to all the elements that will be contributing to the answer of I will be equals to the elements that are starting from the index 0, 1 till I, excluding all the elements that are ending at the index 0, 1, 2, 3, 4 till I minus 1. So, I have formed my answer of I with this particular observation. Right. So, I have already formed my answer of I. Now, computing this whole value every time would have been quite cumbersome. So, I decided to form a generalized formula. Right. So, I tried to find out a generalized formula using answer of I minus 1, and I observed that answer of I and answer of I minus 1 have a lot of things in common. Right. So, what I do is I just take that common thing out and I just add all of those things which were not in answer of I minus 1. So, these two were not in answer of I minus 1. I just add them. Right. So what I'll do is for every index I, I'll just copy all the values from answer of I minus 1, and I'll just add some of my values of my own for the index I. Now, how is this approach applicable to our this particular question which have been given? So what we'll do is we will try to maintain the frequency of each of those bits, right, at each of those index. So at the end, if at the ith index, even if for example, if these are the bits, so if this bit has frequency 1, if this bit has frequency 2, and the other ones have 0, so the answer in this case for the ith index would be 5. Right. So this is how we are going to compute it. We are going to compute our answer. So let me just show you the code now. You will be able to understand the second part of this approach in a much better way while viewing the code. So this is the code, and when I get the function, what I do is I just initialize two vectors called start and end. So these vectors will be storing all the elements which are starting at position I and all the elements which are ending at position I, right? So I just go through all the queries and I just update start of query of 0 minus 1. So why am I doing minus 1? This is just because I wanted to take 0 based indexing and it has no other reason. So this will be the starting range. So I have pushed back the query of 2, that is the variable x, into this particular start vector, and similarly this query of 2, that is the x variable, into the end vector as well. But here I am taking the ending index. So I know what are the elements starting at index I and what are the elements ending at index I respectively in the start and end vector. Now I just try to find my answer in the bit form first, then I later convert it into integer values. So I have created a double dimensional vector of size n, and at each index I am maintaining a vector of size 32 representing the 32 bits, right? So first of all, what I do is for whenever I get it in get at any index, I just try to find all the numbers that are starting at index I, and I'm just doing a bitwise traversal of all the 32 bits. If the jth bit is set, I'm incrementing the counter of bit answer of ij by 1. Right. So this is right shift. Right. This is I'm just doing the bitwise AND of the number with 1. If the statement is true or if it returns 1, then it will be added to my answer. Otherwise, if that particular bit is not set, this will return 0. So this is just basic bit manipulation. Right. Now I check if the index is greater than 0. That means I am at index greater than 0. That means I have a left element to it present. There is that index I minus 1 exists. I'm just making sure that index I minus 1 exists. Right. Now for all the values, for all the bits from 0 to 32, I'm just copying the answer. As I've already told you, answer of I will be equals to answer of I minus 1 plus something, right? So this is that particular part where I'm just copying the value from answer of I minus 1. Now I also have to remove all those indexes, all those elements which have ended at index I minus 1, right? Which have ended before index I. So similarly, just like I have added, similarly I am subtracting. I'm going through all those numbers and I'm finding their bitwise. I'm finding whether the jth bit is set or not. If the jth bit is set, I'm subtracting 1 from the answer, right? So after all this computation is done, I just create my final answer vector, and I just, for each of those indexes, I try to find what is the final integer that is being formed by that particular 32-bit vector, I just go through all the 32 bits and I just check whether the current value is greater than 0. So if the frequency of the ith element and the jth bit of the ith element is greater than 0, then I just increment the value of that is increment its value by 1 left shift j. So because it is the jth bit, that is why I'm left shifting 1 j times, right? So I just add it to my answer, and at the end I can just set answer of I is equals to value. So after all this is done, I can just finally return my answer. So this would be the solution for today's problem, update queries. I know that this approach is a little bit different. You can also solve it with segment trees. It is equally correct. It's just that segment trees the code of segment tree is quite cumbersome. So that is why I will always try to avoid it until unless it is absolutely necessary. As well as this approach is a little bit smart and it will help you to analyze things more. So if you found this video helpful, you can show your appreciation by clicking on the like button, and also you can subscribe to this channel. It's always free of cost, and if you don't like the content later, you can always unsubscribe. Also, don't forget to share this channel with your friends. So till the next video drops, keep coding, stay safe, bye bye.